Stick him on the website. Records it. Yeah. Have I explained this before? Yes. I'll show you again after. Okay. Quadratics make a parabola shape. Its equations in the form y is ax squared plus bx plus c. Okay, I don't care what the numbers, the coefficients a, b, and c are, as long as this is our one restriction. Because what happens if a is 0? I don't have an x squared term. What's the part of this equation that makes it make a parabola shape? This little 2 right up here. Okay? Makes it a quadratic parabola shape. Okay? The simplest one, we saw this yesterday on the worksheet. The simplest possible quadratic is when b is 0 and c is 0. Then we just have, well, actually, and if we let a be 1, then we have y is x squared. That's the simplest quadratic you can have. What makes it a quadratic, a parabola shape? That power of 2. Okay? We didn't look at these in grade 10. They were all linear. They were all lines, because x was to the power of 1, right? Y equals mx plus b. There was no squared, there was no cubed, no fourth power. That does something even stranger to the graphs. Okay? So, what's the shape of this again? We did this yesterday. This thing's going to be your friend. Okay? Simplest possible quadratic, y equals x squared, or, if you like, the power of 2. That's the same thing. Hit graph. There it is. Okay? Now we're going to get all sorts of details about this, like domain, range, the vertex. Does it open up or open down? The y-intercept, the x-intercepts. Okay, we've been playing around with these things for like over a month, 5 weeks. It's a big chapter. Okay? So, shape, what does this thing look like when we graph it? And you can plot this. Remember, anything you can plot, okay, just put in a couple of points. But do we need to do this anymore? Did I tell you a little shortcut yesterday where you can get your own table? Go second function, table, there it is. I want a couple of negatives, there they are. There's your plot points. Okay? This thing looks like 1 is 1, negative 1 is 1, 2 is 4, negative 2 is 4. Okay? And we say the shape of that opens up. Okay? Opens up. Does that make sense? Does this thing have a minimum or a maximum point? It does have a minimum. What is the coordinates of that minimum point for this graph? Right there. I didn't quite hit it. Has a minimum point. Okay? The reason, well, I'll explain that in a sec. It opens up, therefore it has a minimum point right there. That's the lowest this will ever go. How high does it go? Yeah, it keeps going up and up and up forever and ever and ever. What's the largest possible value of x you could think of? Put it in there and then square it That's the value of y. That's why we put arrows on the top of these lines. Okay? On the graph, I didn't tell you to do that yesterday. It was just kind of like an introduction, exploration. But this isn't correct if you just stop it right there. It doesn't just stop there. Okay? There's no restrictions on this. It keeps going forever and ever and ever. It never curves in. Okay? Don't do that. It doesn't go straight. It's not a line. It keeps curving out forever and ever and ever. Okay? The larger value of x, square it, that's the value of y. Okay? So it has a minimum point, no maximum. Okay, some details we need to know. You'll be lucky if I ask you questions that simple on the test, because a lot of them will not be simple. What if a is minus 1? Here, what's the value of a? There's nothing here. So that means a was 1. Okay? I put words yesterday on the sheet like conjecture, guess, maybe what's going to happen if I make that negative. Do we remember from yesterday's sheet what happened? What did that do? All I did was just put a minus in front of this graph. What happened? Some of us know. It doesn't open up, it opens down. Okay? If a is negative 1, if this thing is negative, make my page bigger. Okay, it does this. It opens down. And if you want to plot the points and look and see, well, you can, right? You know how to do that. Does it have a maximum or a minimum? It has a maximum point right there. Okay? Same coordinates as the last one. It doesn't get any higher than that. But what's the minimum? It goes down forever and ever and ever and ever. What's the largest possible number you can think of? Remember, bed mass, you square it first, then put a minus in front of it. Infinity squared, still infinity. Negative infinity. This goes down forever and ever and ever. It has no minimum. Okay? That's what happens when we put a minus there. It's the exact same shape. It's just a word in this. We won't use it in this course, but in pre-calculus, it's reflected over the x-axis. We're okay with opens up, opens down. Okay? Do I want to talk about domain today? No, I don't know. One other thing I want to point out. This is a characteristic of all parabolas. What do you think about, if I draw a line there, well, that's right where the y-axis is. What do you think about the left and the right? How would you describe that? When you look in a mirror, what do you see? Yourself. Okay? If this is you, don't draw this, but okay? And there's your mirror. What you see is, yeah. But what's the word? Starts with an S. About this line, this looks exactly the same as this. It's a reflection. It's symmetrical. This looks exactly the same as this. all parabolas are symmetrical. Okay? There's symmetry going on. The left-hand side looks like the right. I don't care if it opens up or opens down, the left side is exactly the same as the right. And if you noticed when you plotted this thing, okay, look, the points are identical, right? If these x's are negatives, -2, you get -4. If it's 2, you still get -4. It's symmetrical. Every point on this side, there's an identical point on the other side as far as y goes, okay? They're all symmetrical. Okay. Is whoops. Is that a quadratic? We know if something's a quadratic if what happens in that equation somewhere. If we have a squared. Do we have a squared here? What's another way we can check? Do we have one of these? Let's plug it in. Exactly as it looks. X times x plus 2. Is that it? Graph. Does that look like a parabola? Therefore, that's a quadratic. Okay? So remember, grade 9, distributive law, this is the same as this, isn't it? If you multiply it out, I have an x squared term there. Okay? So if we're good with our remembering our basic algebra from grade 9, you'll look at that and go, yeah, that's quadratic. If we're not sure, do that. Plug it in. Picture's worth 1,000 words, right? Okay? You will get basic questions like this. How about this one? Is that going to make a parabola shape? Is that quadratic? How can we find out for sure? I don't remember this algebra stuff. You do this. X plus 1 squared, but if you don't put it in properly, well then, you know, you're out of luck, right? Is that the same thing? Yes, bracket x plus 1 bracket squared. What does that look like? It looks like a parabola to me. Okay? So, if it's a quadratic, it makes a parabola shape. Therefore, we can say the backwards, right? We can say it the other way around. If it makes a parabola, then it's quadratic. And if we remember our algebra really well from grade 10, this thing squared means this thing times itself. And you remember foiling? When you have a binomial times a binomial, yeah, we get an x squared term. First, outside, inside, last. Okay? You can simplify it if you want, but we don't really care. We just want to make sure we see that squared part. Okay? That's definitely quadratic. Okay? How about this guy? Whoop. Negative 0.2x minus 3 squared plus 2. Is that going to give us an x squared term? How hard would that be to plug it in? negative, if you're leading off, remember, you got to use this negative here. 0.2 bracket x minus 3 bracket squared plus 2. Does it look parabolic? Yeah. You think that's an equation for something shot out of a gun from here to here? You know, every video game where anything's thrown, kicked, shot, some guy somewhere is programming it and writing in quadratics so that it makes that shape. Right? I don't care what it is. It's a quadratic. Okay. So it's quadratic. Let's add one more thing here. What is the y-intercept? Because you're going to need to know that. What's the y-intercept? Where it crosses the y-axis. First of all, does it? Because sometimes it might not. Yeah. Where does this thing cross the y-axis? Right there. Kind of looks like 0, 0, doesn't it? Do we trust this? No, that's not accurate enough. I'll show you a way to find it on here, but we hopefully remember what happens at the y-intercept. Always, always, always. So what can I do? How can I find that algebraically? If I know x is 0, I'm going to substitute it right in there. 0 minus 3 squared plus 2. That's a bit of work, but hey, don't I have a nice little tool here? What is negative 0.2? 0 minus 3 is just minus 3 squared. That's going to be 9, but you know what? Hey, just plug it in. My y-intercept is 0.2. Does that kind of look like 0.2? Sure. Okay. That's the y-intercept. Same thing. Don't forget. That's where x is 0. Okay? Ones you're going to do in the book are a lot easier than this one. It's the concept, right? The y-intercept, that's always where x is 0. I don't care if it's a line or a curve. It's the same thing. All right? That's about it for today, guys. That's all you need to know. One little bit at a time. That's still not accurate enough.
No, it is.
Sometimes it'll work, other times it won't.
All I have to do is press trace and then